Today's third week of engineering maths. Today's session is going to be around solving simultaneous equations by both the substitution and the eliminating of the variable methods. And then we're going to look at quadratic equations and solving them via the formula and via factorization methods. Okay, so that's what we're going to be doing in today's session. So, solving simultaneous equations. There are two. We've already seen that an equation with just one unknown variable, we covered those last week, is relatively easy to solve by rearranging that equation to make the variable the subject. That's a reasonably simple algebraic method to do that. However, if an equation contains two unknown variables, has an infinite number of solutions. Okay, but if we have two equations available that express those two variables, then a single solution can be found. So you find both unknowns. Two equations used to solve both unknowns are called simultaneous equations. Note, three unknowns would require three equations, four unknowns, four equations, and so on. Okay, we're not going to do more than two unknowns, because the maths gets a little bit unwieldy, and there's very rarely any point to doing that. So, methods of solving simultaneous equations. Two analytical methods that can be used to solve simultaneous equations. You can do it by substitution and by elimination. You can also solve simultaneous linear equations graphically, although dependent upon what the result is, that might just be an estimate rather than an accurate result, depending on how much you can zoom in. Because the solution, if you graph two linear equations, and this is a graph of x plus 3y equals 4, that's the red one, and the blue one is a graph of 2x plus 3y equals 6. The solution to that is where the two lines cross. So the solution to those two equations, x is equal to 2, but what can we say y is equal to? Approximately equal to 1.4 maybe, something like that. Looking at that, 1.3, 1.4. So that's what we can get from the graphical solution. So if they cross nicely on an intersection point the two axes, then yeah. But if they don't, then that's more of an estimation than anything, unless you can zoom right in with the graphing software. But it is one way of kind of sketching it and estimating a rough area where your result is, so that you know that when you've done the analytical method, that your answer is in the right kind of area, if it matches that. So, I've got two equations there. It's usual to number the pairs of simultaneous equations, equation 1 and equation 2, so that then you can refer to what you're doing with those equations. So, anyone want to offer an idea about, we're going to first look at A by substitution. What do we do? Anyone in the room remember what it means by solving those two equations by substitution? That's the elimination method. Yeah. Any idea what we can do? What does it mean to substitute? Well, if we take equation 1, rearrange equation 1 for x. Okay, we've done that on the previous weeks. We've done that last week. So I'll just pause the video there. Rearrange equation 1 so that it says x equals something. Equations. So we've rearranged, for the benefit of the video, rearranged equation 1 so that it says x is equal to something. Okay. What we then do is substitute equation 3 into equation 2 for x. So wherever we see x in equation 2, we write minus 1 minus 2y. So having substituted x equals minus 1 minus 2y into equation 2, we end up with that equation, which we'll call equation 4. And now it's a matter of solving that equation. So you've got to multiply out any brackets, get one version of y and what it's equal to. So I'll leave you to do that now. Right, what's the method here then? To get that to say y equals something, what do we need to do? First, multiply the brackets out. Yep. So what do I write, Lewis? Yeah. So minus 4 minus 11y equals 18. Add 4 to both sides. Minus 11y is equal to 22. 4y is equal to minus 22 over 11 equals, actually let's write that like that, it's a bit confusing. That's 22 over minus 11. The answer to that is minus 2. So y is equal to minus 2. How do we then find x? Yeah, so we substitute x is equal, y is equal to minus 2 into any of the equations involving x, and then rearrange it to find x. So if we choose equation 1, x plus 2y equals minus 1. Substitute y equals minus 2 into equation 1. So that's x plus 2y, so that's 2 times minus 2 equals minus 1. Then we need to rearrange that for x. So that's, take the brackets away, that's x minus 4 is equal to minus 1. Therefore, x equals 3, does it not? Yeah. So the final solution to this, therefore, solution is x equals 3, y equals minus 2. And does that look right to the graph that was in the question in the first place? Yeah, the two lines cross at the point x equals 3, y equals minus 2. Okay, I'll put it back down. So that is solving that equation using the substitution method. So, elimination, P. Probably the most popular method, to be honest, rather than all that rearranging of equations. Sometimes you need to rearrange them to get them in the right order, but other than that, this one usually the most popular. So, anyone know what we've got to do here? Caleb. Sorry, no, Lewis, you had an idea. Who was it who said an idea and I said, no, that's the other method. That was you, Caleb. So what did you say? Yeah. Okay, yeah. You've got to get the same number of x's or the same number of y's on both sides of the equation. So, to be more precise, you get the coefficient of either variable the same. I'm going to put in brackets and positive. It's usually easiest to make them both positive. Alright? We come up against an example in a little while where you need to get the sign changed so that they're both positive. So the idea here is, we've got these two equations. We've got x plus 2y equals minus 1. That's equation 1. And we've got equation 2, 4x minus 3y equals 18, equation 2. To do this method, the coefficient, for anyone who doesn't remember, is the number in front of the variable. So the coefficient of x in this equation is 4. The coefficient of x in that equation is 1. Yeah. Coefficient of y here is 2. The coefficient of y here is minus 3. The sign goes with the number after it in terms of coefficients. Yeah? So, what we need to do here, we could choose the best option here would be to multiply the top equation, equation 1 by 4, and make the coefficient of x in that 4, so it becomes 4x. So if we write that here, multiply by 4, we're going to do it to that one. We then get equation 3, that is 4x plus, we've got to multiply everything by 4, so that will be 8y equals minus 4. Everyone agree with that? Because I am known to make mistakes. Usually deliberate ones. What do we do now? How can we make x disappear now? Subtract which one from what one? Yeah. In fact, if we subtract, it doesn't matter which one we subtract from the other, does it? Yeah. So we can go subtract 3 from 2. We're going to subtract equation 3 from 2. So if I draw a line under that and say I'm going to subtract the top one, the bottom one from the top one, 4x minus 4x is nothing. Minus 3y plus 8y is minus 8y is minus 11y. And 18 minus 4 is 22. The two negatives make a positive. Yeah. So we've got minus 11y is equal to 22. Therefore, y is equal to 22 over minus 11 equals minus 2, which is exactly the same as we got by the other method. So put that there, same as using substitution. Okay. Therefore, same result for x. So what you would do there, and I don't propose to go through all that again, but you would substitute, then substitute y equals minus 2 into equation 1, for example, to find x. And x should come out as the same value as it did before, because we got exactly the same equations. Okay? So that method there's a little less to do really in that method, although there might be some examples where it might be easier to do substitution. The judgment is yours at the time, really. On the next page, solve by substitution method the simultaneous equations 1 and 2 that are on there. So I'm going to pause the video, have a go, 5 minutes to have a go at that one, then we'll go through the answer, then we'll have a look at a couple more by the elimination method. Right guys, how far we got this one then? Oh, better unfreeze. How far we got this one? What you done first, Dom? Yeah. Yeah. X equals minus 7 minus 3y. Yeah. We called that equation 3, yeah? So you sub that into equation 1 for x. Yeah. So what you got? 3 equals 12. Yeah. Everyone following that so far? See Paul with his thumbs up down there. It's good. And then what you done, Dom? Span the brackets. Minus 21. Minus 9y. Minus 2y. Equals 12. Bring the y's together. Yeah. Minus 21. Minus 11y. Equals 12. Add 21 to both sides. Minus 11 equals, yeah, y. 33. Y is equal to 33 over minus 11 equals minus 3. Yep. Then, someone else now, finish it off. Kyle, put you on the spot. You done it? Who has done the remainder? So what do we need to do? Yeah. Sub y equals minus 3 into equation 2. So what do I need to write then? X plus 3. X minus 9 equals minus 7. Therefore, x equals 2. Yep. All see that, yeah? The elimination method for these two equations. What would you do? We've got 7x minus 2y equals 26. That's number 1. And number 2, 6x plus 5y equals 29. What do you choose to do? Well, we're doing elimination method now, so that involves getting the coefficient of one of the variables the same in both equations. So the first example we had to go at, we had just x on its own, we multiplied by a number. What do we need to do here? Multiply both equations by what? Okay, so you're trying to get y the same. Yeah, that's fair enough. What about x? What would we do if that was x? Yeah, you could, if you can't see a common multiple of 7 and 6, just multiply them together. So if we look at 7 sixes is 42, 6 sevens is 42. So we'd multiply this equation by 7 and that one by 6, and we'll get them the same. Because you may come up against examples where the coefficients aren't whole numbers. So you're going to maybe need to and so the way to do it is to say this one times 6, this one times 7. what we then get is equation 3, 42x minus 12y, and 6 times 26 is, sorry? I'll take your word for it. And then we get equation 4, 42x, because we're multiplying by 7 now, plus 35y equals, the 729s are 203. Okay, and then what we do is subtract 4 from 3. And that's just the same as we've done before with the other one. So just involves an extra step. So that becomes nothing. Minus 12 minus 35 is minus 47. Y is equal to, and 156 minus 203 is, Jake, minus 47. Therefore, y is equal to 1, is it not? What we then do is we can substitute y is equal to 1 into any of those equations. So substitute y equals 1 into number 1. We might as well use one of the simpler equations. We get 7x minus 2 times 1 equals 26. Multiply out any brackets. 7x minus 2 equals 26. 7x is equal to 24. We've gone wrong anywhere? Or hadn't I? X is equal to 28 over 7 equals 4. Okay? Right. What I want to do now is just take a look at a problem that's related to a real engineering problem. And you're going to come up against this, possibly in science in second semester, certainly in electronic principles in a third year. It's a circuit where you've got 2 voltage sources. And so one method of solving that and finding the value of the currents I1 and I2 is to form a pair of simultaneous equations. We're not going to go through the process of forming those equations. That really is for the electrical module and science module, the method you go through. But we've got a circuit here. Just briefly, there's a 27 volt source there, sending a current that way through that part of the circuit. There's a 26 volt source, and we've got a current flowing there, and then those 2 currents, by the laws of science and electrical, combine together, and a current will flow through the 8 ohm resistor. Yeah. The only there are a number of methods we could use to solve that circuit, and the method used to depend on exactly what we know at the start of the problem, and also upon which values we're interested in. So there's a number of methods you'll eventually learn to do this. But you're given two equations here. 27 is equal to 1.5i plus 8i minus I2 in brackets. So there's two equations there to solve. Okay, we've got, I'm going to write them out a bit bigger for the benefit of the board. 27 is equal to 1.5i1 plus 8i1 plus I2. This bit comes from the fact that the two currents flowing in the top line here combine together by Kirchhoff's law to become the current flowing down the middle. And we got a second equation that says minus 26 is equal to 2 times I2 minus 8 times I1 plus I2. What's the first thing we need to do here? Multiply out the brackets.
Well, I don't like to simplify it, then you have to easier equations.
1 and 2, by the way. Multiply out, so what you're going to do, multiply out the brackets in both equations?
Yeah, that's what I did.
So, yeah, this half of the room, multiply out the brackets in equation 1. This half of the room, multiply out the brackets in equation 2. And I'll pause the video. When you get to that stage, yep. Do all my left-hand side agree with that? Yep. Everyone on the left-hand side agree with that multiplying out of them brackets, yeah? 27 equals 9.5i1 minus 8i2. Yep. So we'll call that equation 3. Kyle, picking you. What? You're not. So have you done it or not? Because getting it wrong is not a problem. Oh, put you on the spot then. Multiply out equation 2. What we got? You're on the right, mate. Do you agree with what we got for 1?
Yes.
Jack, I'll put you on the spot then. Yeah. Minus 26. 2i2 minus 8i1 plus 8i2 minus 26 is equal to 10i2 minus 8i1. That gives us equation 4. Yeah? Right? So the next step is we've kind of got a little bit of an ordering issue here, haven't we? Because if we're going to line these up for subtraction, we need to get the order the same. So how can I rewrite equation 2 so that it is I1 first and then I2? Yeah, so we'd write this one as minus 26. Well, sort of, yeah. All we're doing is getting the I1 first. So that'll become minus 8 I1 plus 10 I2. Does everyone agree with that? There's an unseen plus in front of this 10 that we don't write when it's like that. If we shift it over that side, we write it. We've still got the same thing. Yeah, we'll just rearrange the order of 4, that's all. Next job. We've got to get the next part of this method, if we're going to use elimination, is to make the coefficient of one of the two currents the same in both equations. Which one would you choose here? Yeah. I'll choose I2 because both the coefficients are whole numbers and no decimal, where you've got a 9.5 in front of I1. Okay. Also, we got two coefficients, one is positive and one is negative. So let's just draw these out here. There are two equations I got. If ignore that sign for a minute, ignore the minus 8. If I multiply the top one by 10 and the bottom one by 8, I'll get the numbers the same. If I multiply the top one by minus 10, I'll change the sign of that 8. So they'll both be positive 80. So I'm going to multiply that one by minus 10 and that one by 8. Yeah? So we end up with 27 times minus 10 is minus 270. 9.5 times minus 10 is minus 95. I1. And minus 8 times minus 10 is plus 80 I2. So that's got the coefficient of that I2, so positive 80. Then I'm going to multiply the bottom one by 8. Minus 26 times 8 is minus 208. Minus 8 times 8 is minus 64 I1. And 10 times 8 is plus 80 I2. Now we've got our two equations we want that will allow us to subtract and eliminate one of the variables. So we go like this, and we subtract. That bit is nothing. Minus 95 minus minus 64 is and minus 270 minus minus 208 is minus 62. The two negative signs turn into a positive list, don't they? So that's same for what? Minus, it's minus 95 minus 64. This is effectively minus 95 plus 64. Which is minus 31. Yeah? Right? If you're unsure, plug it in your calculator. So minus 62 is equal to minus 31 I1. That rearranges to I1 is equal to 62 over minus 31 equals minus 2 amps. No, because you're going to add. Oh yeah, yeah. Minus 62, minus 31, 2 amps. Beg your pardon. All right. Everyone happy with that so far? What remains is substitute I1 equals 2 amps into one of the original equations. Which one should we choose? Minus 26 one. Tell me what to write then. Which equation is that, 1 or 2? Equation 2. So we go minus 26 is equal to 2I2. Actually, is there a better one we could choose? One of the multiplied 8 ones. Yeah. So we choose minus 8I1 plus 10I2. Minus 26 equals 8I1, was it? Minus 8I1? 8I1 plus what? 10I2. So we're going to substitute I equals what? I1 equals 2 amps into that. So that becomes minus 26. It's minus 8 times 2 plus 10 I2. All follow that so far. Minus 26 is equal to minus 16 plus 10 I2. Add 16 to both sides. Minus 10 is equal to 10I2. Yeah. I2 is equal to minus 10 over 10 minus 2 amps. What did we... 1 amp. Yep. Now, that's kind of not that relevant to this module, but it will be when you look at the science and the maths. If you get a negative current, it doesn't mean that your answer's wrong in this type of problem. Because when the process of formulating those two equations in the first place means that you have to pick a direction for your currents and put an arrow on. All a negative current means is that that current is flowing against the arrow on the diagram, so the current's actually going in the opposite direction. So if you look at that diagram there, and we got that's I1 that's negative, isn't it? No, I2 that's negative. So on the diagram, I2 is shown as flowing that way. Because it come out as a negative answer, there's actually 1 amp flowing in that direction.
Is that why that on that 26 volts there it's pointing the other way?
No, the arrow on the voltage indicates that that end is positive and the other end is negative. It indicates the polarity of the voltage on that there. I don't want to go into too much because that's a science thing and we're in a math session, okay? But to actually formulate those two equations in the first place, you'd need to pick a current direction. Yeah? And what you would normally do is say which way is it going by convention, and then if you end up with a negative, that means it's actually going the other way. Down. So we're looking at this problem now. We've got x over 8 plus 5 over 2 is equal to y. It's equation 1. And we've got 13 minus y over 3 is equal to 3x. So we've got an ordering issue and we've got fractions. What are we going to do?
Try and 13.
What make it thirds? Yeah. You could do, possibly. Well, you do want to do that. You want to get a constant as equal to an x term plus or minus a y term. Yeah, you want them in the right order. But the main method here is to get the coefficient of one of the variables the same. Is that not really tricky with fractions? Is there something we could do that would remove the fractions rather than putting more fractions in, Paul? Because if you turn them into all into fractions, you're just kind of adding to the problem. Yeah? Because to turn this into thirds, you're like 13 over 3. That's kind of tricky. But how can we remove the fractions? How do we make them all numbers? Would that help? If I turn that into 8 divided by x there, would that help? How could I eliminate that 8 underneath there? I've got... If we can make it 8 divided by 8, they'll cancel out. So if I do that, the 8's will cancel and I just got x. But if I do that, I've got to multiply this by 8 as well. And I've got to multiply that by 8. Now, that goes, that becomes 20. So what we end up with is x plus 20 equals 8y. Now, remember what we said before, if you're unsure whether that's true, give x and y a simple value and plug it into that and plug it into that and see if they're both true. So if we said x is 1 and y is 2, what would this be equal to? Oh no, we can't do that with two variables, can we? No, that's the only one we got one, sorry. So we've done that. Yeah, everyone agree with that? So what do we got to multiply this one by? 3. So we've got to do 3 times 13 is 39 minus, that'll be 3y over 3, yeah, is equal to 9x, which cancels out here. These two cancel, so that's 39 minus y equals 9x. Everyone agree with that? Now what do we need to do? Yeah, add y to both sides on here, so we'll have 39 is equal to 9x plus y. You want to take away 9x. You need to do that? We want the two equations, that one and that one, in the same order, don't we? Okay, yeah. I can see what you're doing. 39 minus 9x equals y. Yeah, so you got y over on the right hand side of the equals. And now we need to get these two in the same order as that, don't we? So you can just swap those ones round, can't you? You can make that 20 plus x. So you can do 20 plus x is equal to 8y. So now we've got them. If we bring this one down, we've got these in the same order. We've got the number on its own, we've got the x term, and we've got the y term on the other side of the equals. Next job. We've got two options really, haven't we? The top one by multiply the bottom one by 8 to make both of them 8y, or multiply the top one by minus 9. So, yeah, well, I'd certainly multiply this one by 8 if that was me. This one here. So we'd end up with 39 times 8 is 312. Minus 9 times 8 is minus 72, is it not? Is equal to 8y. Everyone agree with that? No, that's if we've multiplied this one by 8. Yeah, we can now take this one and subtract from it. So we can put 20 plus x equals 8y. and subtract. Agreed? Or not? 292 equals 73x. X equals 292 over 73 equals 4. 292 equals 73x, so you divide both sides by 73. I've added, this is add 73 to both sides. Four, isn't it? So from there, I've done that subtraction. I've then added 73 to both sides to end up with 292 equals 73x, and then divided both sides by 73, so x is equal to 292 over 73, which is 4. I subtracted these two equations, that one from that one, which eliminated the y's. Yep. And ended up with 292 minus 73x is equal to nothing. I then added 73x to both sides, so that shifts that over that side. 292 equals 73x. I then divided through both sides by 73 to end up with that as equal to 4. Okay? We then substitute probably one of the ones with the fraction removed, which should be, let's go for x plus 20 equals 8y. So we got 4 plus 20 equals 8y, 24 equals 8y, y is equal to 24 divided by 8 equals 3. So the solution to those two simultaneous equations is that x is 4 and y is 3. If we graphed them, we'd find that the two lines would cross at the point x4, y3. Yeah?